Okay, hi everyone. We're just going to get started now. So, welcome to the data analysis workshop. My name is Zara Yu, and I'm just going to be covering some overall topics that have to do with data analysis, like the steps to doing it and statistical methods. So, our topics that we'll be covering today are what is data analysis, statistics behind it, steps of data analysis, and how it pertains to machine learning. So, what is data analysis? It's essentially the process of inspecting, cleaning, transforming, and modeling data to discover useful info, informing conclusions, and supporting decision making. So, in other words, it refers to techniques to analyze data that enhances productivity in scientific advancements, or it can be applied to businesses. So why is it important? It's important for producing a statistically significant result that can be used to make decisions. And this for data analysis, the steps that they take are first, they work to collect data. So this can be done with surveys, questionnaires. It can also be done with like market research if you're doing businesses. And that's just pretty much it for that. Then analyzing data, it's pretty much done with statistical methods, such as maybe finding the average of something or the range. So we'll be talking more about that later. And finally, they have to report this information to whoever they're working for so that the people who requested this information can change whatever is necessary. So they'll create a report for that. So statistics is a type of mathematics that involves collecting, organizing, analyzing, interpreting, and reporting data. So there's two different kinds of statistics that we'll talk about. The first one is descriptive statistics, and this essentially uses data to provide descriptions of the population. The next one is inferential statistics. So this generalizes a large data set with a sample and uses probability to get a conclusion from that sample. So it allows us to infer data parameters based on a statistical model using a sample of data. So this is just the difference here. Descriptive statistics makes some conclusions about the entire population, while inferential statistics kind of draws on probability methods instead. So here you can see the difference between the two. Descriptive has to do with properties of the population. It uses charts, tables, and graphs. It describes known data, and it uses measures of central tendency and spread of data. So measures of central tendency pretty much mean mean, median, and yeah, like that. And spread of data means range and those kinds of things. So I'll be talking more about those later. Then inferential statistics makes inferences from the sample. It compares or predicts future outcomes. It uses probability scores, and it uses hypothesis testing and looks at variance, which I'll also be talking about later. So here are some steps for data analysis. The first one is we have to determine our data requirements, because obviously if you're doing data analysis, you need data. So data is collected from this thing called an experimental unit, which it could be a person or it could be like an object of some sort. So specific variables about this regarding the population can also be obtained, which is like age and gender, or maybe location, income, all these kinds of things. It kind of depends on a case by case basis. The next thing we have to do is collect that data. So it could be done with interviews, surveys, observing satellites, recording devices, maybe cameras, then documents and records. So all of these things can be used to find your data. The next thing is data processing. So data has to be organized before analysis. Many data analysis use things like Excel or Google Sheets for like quantitative kinds of data. So they'll just list the numbers in each row and column, or you could also put like qualitative data in it. It kind of depends, but this is what most people use. Then there's also data cleaning. So after your data is organized, you can find that it has duplicates, it has errors, or it's incomplete. Like if you're doing a data from people, then some people might not have the information that you need. So you have to take them out, and then you have to find more people that have the information that you want. So data cleaning is the process of preventing and correcting these errors. And it consists of record matching, identifying data inaccuracy, overall quality of existing data, deduplication, and column segmentation. So there's different kinds of data cleaning that depends on what kind of data you actually have in the set. So you have to determine it again on a case-by-case basis. Then we have to do data analysis. So after you clean your data sets, it can be analyzed after, and this is referred to as exploratory data analysis. So data exploration can result in additional data cleaning sometimes, or maybe they want more data in order to do this exploration. So data visualization is a technique used where analysts can examine the data in some sort of graphic format. So they can use like charts and tables and stuff to see it in a visual manner. Then you have data algorithms and modeling. So models, mathematical formulas, or algorithms can be applied to data to identify relationships among variables. And models can be developed to evaluate a specific variable based on other variables in the data set. So like, for example, graphs, you can compare one variable with another one by plotting them on the X and Y axis respectively. Then finally, there's communication. So after your data is analyzed, it can be reported in a variety of different formats to the people who are using this analysis. So if the users have feedback, more analysis can be done accordingly. And analysts use data visualization techniques to convey their data sometimes. So this is also tables and charts and such like that. Now we can talk about some statistical methods. So our first one that we can observe is mean or average. So arithmetic mean is called average, and it's useful in figuring out the overall trend in a data set or providing a quick overview of your data. So you've probably all learned how to calculate mean in some of your math classes, but if you didn't know, it's just the sum of a list of numbers divided by the number of items in your list. So when using it alone, it can cause some issues. In data with lots of outliers, which are data points that are way out of the range of the other ones, or it could be a skewed distribution, which means that some points are clustered on the left side compared to the right side. So your mean wouldn't be that accurate. So it wouldn't be able to make a significant conclusion. So this is just some drawbacks to doing it. The next thing is standard deviation, and that's just the measure of the spread of data around the mean. So higher standard deviation means that the data is farther away from the mean, and lower standard deviation means that it's closer with the mean. So it aligns further with the mean. So it can be useful with determining distribution among the data points, but it can be misleading if you solely use that by itself, because if the data has a weird pattern to it or has a lot of outliers, the standard deviation wouldn't just give enough information. So you have to look for more things, but this is a good tool to use. The next thing is regression. So regression models the relationship between dependent and explanatory variables. And this relationship is usually on a scatter plot. So these lines tell whether the relationships between these variables are strong or they're weak. So if it looks more like a line when you graph it on scatter plot, it means the relationship is strong. But if the data points are more spread out, it means that they're weak. So outliers on a scatter plot can sometimes matter significantly. However, regression lines tend to ignore these outliers. But sometimes these outliers are important. For example, if you're a business and you have a top seller that buys the most amount of product from you, they kind of wouldn't be affected by the regression line wouldn't be affected by it. And it could matter because obviously they're buying a lot of your products, so they would impact into your sales. So sometimes it's just not nuanced enough to help you in your data analysis. Another thing you can use is sample size determination. So when you're measuring from a large data set or population, a sample can do the same job as collecting information from every single member of the population. So if you use proportion and standard deviation, you can determine the correct sample size that'll help you make your data collection statistically significant. And this is useful because it could be more efficient than actually having to collect information from every single person in this population, and say you could just do a sample, which is a lot less people, and you could get the same amount of results pretty much. So when studying a new variable in a population, your proportion equations could rely on certain assumptions, but these assumptions might not be accurate. And this error could then negatively affect your sample size determination and change our data analysis. So sometimes this could cause our sample size to be too big or too little, which would then be unhelpful to us rather than more productive. So this could just be a drawback. The last thing I'm going to talk about is hypothesis testing. So this determines if a certain assumption is true for your data set or population. In statistics, the results of hypothesis testing are statistically significant if the results couldn't have happened by random chance. So if you get a result that couldn't just have happened on coincidence, that means your result is statistically significant. So some downfalls of this are you have to watch out for common errors in hypothesis testing. One example is the placebo effect. So this is when participants falsely expect a result and then perceive that result. And an example I could give for this is if a doctor is giving a patient like a sample, a testing pill, and they tell them it's going to cure some sort of disease they have. There's a chance that it doesn't actually cure the disease, but the patient feels like that they're being like cured, and they falsely just say that it's helping their health, but it's not. That's what the placebo effect means. The next thing is the Hawthorne effect. So this is when participants skew results because they know they're being studied. So for example, if an officer is like surveying a citizen and they ask them if they've taken illegal drugs or something like that, the participant's obviously going to say no because they're being questioned by a cop. So this would skew your results. This is just an example of the Hawthorne effect. So those are the statistical methods that I'm just going to go over for this. We're going to talk about an example case first, which I'm going to go over with you guys. And then after, I'll give you another example case that you can try on your own. So this is your background information. The researcher is trying to figure out which dog breed is most suitable for households that have children. So this is just a picture of some. So for our data requirements, we have to think about a variety of different things. For example, how well the dog breed adapts to living in homes, how affectionate they are with families, their amount of shedding, how friendly they are with smaller kids, and how easy they are to train. These are just some things we can think about when we're collecting data. So in terms of data collection, we can do some desk research by looking at dog sites, just like informational websites that give you some things on dog breeds, or you can survey dog owners and have them talk about their own experience with different dog breeds. That's another method you could do. Of course, there's definitely a lot more, but I just listed out a few examples. Another thing, the next step we have to do is data processing. So an example I put here is you can use an Excel sheet and you put each dog breed into columns and then put the list of the characteristics in the rest next to them. So that's an example. So make sure all the characteristics are described in the same way for data cleansing. So with amount of shedding, you have to make sure that you list them in the same way. For example, if a website puts it like a dog sheds a certain amount of hairs or something, but another website says a different dog breed just like sheds for a certain time, you have to make sure that they all have the characteristics described in the same way. So with shedding, list the times when a dog will shed instead of like how many specific hairs they shed. So do they shed seasonally, annually, etc. So you could do it like that. So for data analysis, you have to figure out which dog breed has the optimal characteristics to be in a household with children in. So this would be like adapting to houses well, affectionate with families, low amount of shedding, friendly with smaller kids, and easy to train. So once you start looking through your spreadsheet, you can kind of determine which dog breed has this optimal characteristic. And with data modeling, you can check if there's a correlation between different dog characteristics. This is just an example. So you can say like, is friendliness with smaller kids associated with easiness to train? This is just an example. You can make a spreadsheet with that. So that's an example. Then for communication, use a table to show the different characteristics for each dog breed. And you can just order it from most optimal at the top to least optimal at the bottom. So you can kind of get a feel of which one is best and which one's worst for houses with children. So now I'm going to talk about the second case. Now that you've got an idea on how to do this, so my background information, I kind of took from my own personal research project. And what I did was I figured out the correlation between common COVID-19 symptoms and the chances of having COVID-19. So you guys don't actually have to complete this research project because obviously it would take a long time to do. But I want you to just go through some of the steps of data analysis to see if you can figure out what exactly you would have to look up. So the first thing here is data requirements. So I'm going to give you a few minutes to think about it. And once you have some answers for what you would put for data requirements when you're researching this kind of thing, you can send it to me in chat. Okay, some people sent answers, but I'll give other people a few more minutes to just think about it and send me something. Okay, so I got a few answers. One of them was obviously a list of COVID symptoms for each patient. So what symptoms did they exhibit? That's one. Another one was if they're vaccinated or unvaccinated, so we can put that down. Okay, let me look at the other ones. Another one was underlying conditions, then age, then transmission rates. You can also do like if they had the COVID test or the results. So you can see if the patients actually had COVID with their symptoms or if it was some other kind of disease like the flu, since the flu has similar symptoms. So yeah, these are just a couple of things we can put down. And when you're obviously doing your research, you have to keep in mind those things. So the next thing we want to look at is data collection. So how would you go about collecting your data? And if you say something like websites, try listing some websites you can look at online. You can actually do a little bit of desk research right now if you want. And I'll just wait a few minutes for some answers. Okay, I'll give a couple more minutes for other people to send in some answers. Okay, so the first thing I got was surveys. Yeah, you can survey people and ask them, for example, if they've exhibited COVID symptoms before or if they've taken the test, but that could be a bit risky because some people might not want to give out personal info like that. So with that, you'd have to just make sure that the people you're talking to aren't lying about what symptoms they have, but that would also be kind of difficult to do. But yeah, that is one thing you can do. Another thing you can do is some desk research. So if you're looking up symptoms, you can use CDC's website, which I already got as an answer. Another thing you can do is, let me see what other people put. Yeah, for finding transmission and vaccination rates, you can use New York Times. They probably have a database, so I can put that too. That's another thing we could do. So another thing I would say that you could also do if you're doing desk research is there are COVID-19 like patient databases where people or like government sites, they'll post like anonymous people, but they'll post like their COVID-19 symptom information and like their transmission rate, their age, like if they had any conditions before. So you can look at like COVID-19 databases and you'll definitely find some. Another thing you can do is you can look up other people's research papers that have to do with COVID-19. And if they did some sort of analysis like this, you can see which databases they collected from, or you can even see their own data collection because a lot of official papers put their what data they use. So you can also look at that. So these are just some things you can do. The next thing we have to go over is data processing. So how would we organize our data properly in order for us to analyze it after? I'll give it another few minutes to think about it. Okay, for a hint, you could think about how you would organize an Excel sheet to fit all your data in it and make it neat. Okay, for this, I would say, for example, in like your rows, you could just say the age of the people that you collected data on, just so you can separate them properly. Then for your first column, you can say something like their location. Then you can say the symptoms that they have. Then you can say like their test results. You can say their other medical conditions. And you just keep going this way as you collect data. And then as you keep going down the row, you just put down each new person's age. So that way you can separate it easily and just see symptoms, results. So it's organized well like this. So this is what I would do, I'd say. Yeah, and you can add a lot of other things to your columns. There's a lot of things you could put in as you're collecting data. So then after you do your data processing, the next thing to do is data cleaning. So first, you can send me in chat some like data errors you can find, and then you can say how you'd clean them up. So like what problems would you encounter while doing data cleaning? But yeah, so when you're doing a big type of research project like this, there's obviously going to be a lot of people to collect. For articles that are published in big magazines like Nature, you'll have like up to like more than 10,000 people. So you would have a lot of rows to go through. So you have to make sure you organize it well. Then of course, you can also maybe do this not by hand. You can have like your computer upload the information. But yeah, it would take a long time to do something like this, a big project. Okay, for something like this, in terms of data cleaning, you're going to be taking patient information from a lot of different sources. So when you're taking it from these different sources, they're obviously not going to be organized all the same way, and they might not even have all the different same kinds of information. So if you're having like set columns and stuff like that, you have to make sure that each patient has the stuff you're looking for. So for example, if a patient's missing like symptom information, then that's pretty much useless to you, so you can't use it. So when you're doing data cleaning, you have to make sure that all the patients you're taking from have the same data that you're looking for, and it's all like organized the same way so that you can properly do your analysis. So that's what you would do for data cleaning. So now for data analysis. So how are you measuring the comparison from your COVID symptoms to your test results, which is pretty much what we're doing. So like how would you get that done in statistical methods? You guys can take some time to think about it. It's kind of a hard question. So yeah. Okay, so for this, I think what most people would think is the first thing is when you're going through all your patients, if there's like one symptom that's always in every patient with COVID, then that's pretty much automatically a sign you have COVID. Like if every patient had a cough, then it's just a big sign. But that's not always the case, and it's not a very statistically significant method to use because even if you take like a small sample, like 10,000, there's millions around the world who've gotten COVID and it might not apply to everyone. So you can't just say that off the bat. Something you could do is first you can compare with like scatter plots, just using graphing methods. And that's just one way to go. Personally, I used a quantum classifier, which is pretty much like a graphing system where you plot two symptoms, and on the inside of the graph, it'll color the areas where there are COVID symptoms and there's not. So that's like a method that I personally use. But there's probably other ways that are based more around statistics and probabilities that you can also think about. But when you're doing something like this, you can't automatically jump to the conclusion that one symptom applies to everyone in your sample, so that must be a sign of COVID. You just can't do that. It's not very accurate. So that's just something you can think about when you're doing data analysis. Finally, data modeling. When you're, I think that's the final, okay, before communication, data modeling, how would you present your data while you're communicating? So what type of model would you create to show your results for this correlation? I'll give a few minutes so that you can think about it. Okay, so I got a couple of good ideas. The first thing is a line graph. So what you could do, let me see if I can draw it. You can plot uh different variables that you found. Like this would be variable 1 here. This is variable 2. You can draw a line accordingly with the relationship and then graph different points on either side. And you can kind of see which sides have uh COVID and which ones don't. So this one would be like a different color from this one. So that is one way that you can do it. Another way is a 3D scatter plot. I can try drawing that too. It would be something like this. So each axis would also just be a different variable. So one would be variable 1, would be variable 2, one would be variable 3. And you can again split it. So each data point is like red if COVID, blue if not COVID. So then you can kind of determine which areas are more grouped together, find some clusters, and that's just another way. So those are pretty good ideas. That's a couple ways you can do this data modeling. And personally, for my own research project, I did do something similar to like a line plot where I made like a curved line instead, and you put red ones on one side, blue ones on the other side. But of course, there's different ways you could do this. So finally, for communication, I think it's pretty simple. You would just make your thing into like your findings into some sort of paper. You can include your model, and that's just how you would communicate your results to whoever maybe hired you to this data analysis or just for yourself. So you have all your thoughts organized into one single report. So finally, I'm going to talk about how data analysis relates to machine learning, which is a very hot topic right now in the scientific community. So machine learning, if you didn't know, is a concept where machines learn from experience rather than being programmed to do one set thing. So examples of this are like robot technologies. Maybe you have like an Amazon Alexa in your house. This is kind of an example of machine learning. It'll kind of build on whatever commands you give it, and therefore it can get a routine instead of having some sort of set thing that's programmed to do. So the machine obviously has to conduct its own data analysis because it has to process the data that is being given, and it has to use that data to get information on what it's supposed to do. So with machine learning, the machine is kind of having to process these different kinds of data it's getting. For example, with like a Google Home or an Amazon Alexa, whatever commands you give it, it'll kind of process it. For example, if you say like turn on the lights at a certain kind of day, it'll have your routine set so that it remembers what you're doing. And at that time, it might ask you like, do you want to turn on your lights now? So this is kind of an example of that. So this is pretty much how it pertains to machine learning. There's definitely a more in-depth thing if you want to learn more about it. So you can just kind of think about it on your own. But that's pretty much it for my presentation. Thank you very much for listening. And I hope you check out other Logistem STEM application workshops for the future. And that's pretty much it. So bye and have a nice day.